All right, so we're back for video tutorial 4 related to Lab 1 with our interpolations. So all I've done that I've kind of cut out is I added the Utah 21-22 XY table to point features. I've turned off the normals. So there are some differences. They're not exactly all the same points, but that's okay. We're going to compare their interpolations. I've removed the other interpolations from the Utah normals because I decided I didn't like them as much as the Kriging. Remember that these were showing up kind of slowly when we were looking at this before. And I think part of the reason is actually with the Kriging data, there's a lot there. If remember, we had to produce an output statistical data set, and actually that's located here. I think that we will see this pop up here in a second. It's trying to. Um, Taking a minute. So I'm going to turn it off and show you that way. So if I click open there, you can see that there's actually a lot that you can tune and see. So right now we've got this look view that we're looking in this window here across the data, which is color coded like this. And we can see the different simulation runs, these smooth curves, and the point data. And so how those different simulations are fitting, statistically fitting the points that we see and the preferred one that it chose through there. And so there's a lot of things that you can do. You can visualize the standard error of how the model did, um, and other things in here. And I think you can even tune um, here what you did. So like you could explore what might be a better way to go, and then output that uh, again. So you could kind of do this iteratively, and that's really what Bayesian is all about, right? It's to statistically model through the data as many options as possible to find the one that works best. So this is a great tool, but it is processing intensive, so it can slow your computer down a bit, just so you know. So I've turned that one off for visibility, and things seem to have sped up. Okay, so that's one thing. The next thing, other than saying Kriging is great, especially when we have that Bayesian tool, um, I also, as we discussed in class the other day, we have an issue with our 21-22 data, where the 2021 and 2022 are the precip data is in the same column. And we want to interpolate on this data, but we only want to do it by year. So we need to have to separate the precip into a 2021 precip and a 2022 precip. We could add a new field for each of those and try to do like an if-then statement. If date is 2021, then give us precip of that one. Uh, yeah, but then it's going to create holes. We do already have some nulls. There's no data that year at this station, but I don't think that's the way to go to operate within the existing attribute table. I think what we want to do is select the 2021 data and output that to a new file. Okay, so best way to do that is to go to, I think we can actually go back to map. We go select by attributes. We say make a new selection, and we say where date is equal to the option of 2021, apply. And so that should get most of our points, okay, except for any that are missing, I guess. Um, and then so boom, we got those. Now what do we do? So we right click and we go data, export those features, and we'll call it now Utah 2021 piece precip, PRCP, and say okay. Okay, so there's my 2021 precip data. So before we had 585 records. It said we've selected 294. If I open the attribute table, there should be 294 records, and then you can see they're all 2021, and then you can see the preset. So that should work well. Okay. So now we go back to this one. We could actually switch the selection is probably the quickest thing. So now all the 2022s are selected unless somehow there was a null. I think there aren't nulls in the date. So I'm going to trust that. And now I'm going to export that data again. If you wanted to be a little bit more careful, you could reselect by attribute and put 2022 just to be sure you're not getting something else. There really shouldn't be anything else in this table, so I'm going to be a little lazy. Okay, so Utah 2022. Oh, wait, I've got the wrong one here. Got to go back to that one. Data export features, Utah 2022 PRCP. Okay, so now I should have 291 records in that new table, and I do. So I'm going to turn off the old one. I'm actually going to remove it even. Okay, so now I want to interpolate with kriging on both of those. Okay, so let's input 2021, precip, and we're going to call it, oh, wait, we wanted to go in empirical Bayesian kriging again, because we had some nice tools there to make this a little bit better. So we're going to just do exactly what we did before. So precip, and so we're going to call it the similar way. So in EBK, output stats, did I say, yeah, stat underscore Utah 2021. And then EBK no stat underscore Utah. Oh no, EBK Krieg. And then underscore Utah 2021. I'd like to be really consistent there. In our environments, we copy one of those. WGS 1984 to 2011. Output extent of Utah boundaries, mask of Utah boundaries. When you get the tool set up like this, it's actually possible to save this tool too, so that you kind of save. I think you can save your selections, but anyways, and then you might also be able to put in a parallel processing factor to make this run a little faster if it's slow for you. If you specify a percent value, the number of processes used will be specified percentage of the number of cores on the machine rounded to the nearest integer. For example, a 4-core machine setting 50%, 2 processes get up 2.64 to 3 to 100%. So let's just give it everything we got, 100%. See if it runs a little faster. Okay, so now let's go back. We've got to make sure we do this the same way. So we want 2 kilometers. And it was, I think, log empirical because we want to know zeros. All predictions will be positive. Semi-variogram choice, I left at default. I left that as default. And then I did a search radius of 2 and the minimum of 6 points. And the maximum of 15. So it's going to look at the nearest 15 points, and we'll output the prediction. So the other things you could output would be those different statistical measures from our prediction. But the prediction is what we want to treat as truth. So that's what we want for comparison. So I think we're good to go. So I write all those things down see how fast this runs with all my parallel processing. I think I have like eight cores on this thing. Can't tell if it's going faster than before or not. Well, it ran anyway. Okay, so I'm going to turn off the geostats. And then I haven't changed the color scheme yet, but you can see we have a similar sort of thing going on. And so if I'm gonna first run my other one so that I can save a lot of this and keep things simple. So I'm gonna go to 2022. I'm going to change this to 2022, this to 2022, leave that the same. So you can see why I'm doing this, right? By not, I was going to change my symbology to match the other thing at first, but better to not leave the tool because it saves everything that you did. So let's just run it with 2022. Save a little time. Okay, so now while that's running, I probably can go to symbology and match the other one. So import from the Krieging. Yeah, and so because I specified 100% processing on the other tool, it has to wait for the prior one to finish. We could look at view details for the processing if we wanted to. Yeah, and so one finished and then it immediately did the other one. And then we want to do that again, right? So we want to change input layer 2022, match that other one. And I should have turned this off. So now I'm going to turn off my original input data. So there is my 2022 rainfall interpolation from Krieging. There's 2021. So 2022, 2021 are definitely different. I can see that, their symbology is similar. So I think showing us 2021 had a lot less rain, especially in the lowlands. The high areas don't seem very different. I should be a little bit careful about applying the symbologies because it probably, yeah, you can see that it capped the high value the same way. So if I go into the symbology and then look at the histogram, for 2022, we can see that it goes up to 47 or so. Okay, so that's not wrong then. If I choose then 2021 symbology and the histogram values go up to 53.4. So they're both underneath the long-term averages for like the highest station, which I believe is what we use to average things. Let's see. Actually, we originally imported this from IDW, if you remember in the other video. but it's about right. Okay, so the highest value we actually have is 54. And if we go into the original data, and we sorted precip, sort descending, 49 on that one, sort descending, 54 on that one. And if we looked at the Utah normals, sort descending, that station usually has almost 56 inches. So I guess the capping value is not unreasonable. So it seems good. Okay. Okay, great. So from there, right, you would want to bring in your grids from Utah's rainfall as interpolated by the Oregon State University PRISMS group grid, and you'll have to clip that to the state of Utah, and then make like a 4-map figure comparing all those data from those 2 years, and then the average data from these interpolations as well as PRISM. I will stop this video here, and I'll probably make another video talking about that.